Hello students. Hello students. Welcome to Automotive Component Design. We are in Module 2. We are solving design of shaft problems. In the previous classes, we have solved several problems. Now also we are going to solve one more problem. Let me read the question first. A steel solid shaft transmitting 15 kilowatt at 200 rpm is supported on two bearings 750 mm apart and has two gears key to it. See, in the question, they didn't give any diagram. We have to draw the diagram by ourselves. Okay, so a shaft is there, and this shaft is supported by two bearings on either side, and the shaft length is 750 mm. Okay, let me read the second line. The pinion having 30 teeth of 5 module is located 100 mm to the left of the right hand bearing. So if D is right hand means suppose if D is a right hand side means a gear is there and gear is located 100 mm from D. So this is gear. This gear is located 100 mm left to the right hand bearing. Okay, va? Okay, right. Next. The gear having 100 mm teeth of 5 module is located 150 mm to the right of the left hand bearing. So one more gear is there, that is gear B, and gear B is located 150 mm away from bearing A. So a shaft is there, shaft length is 750 mm. Shaft is there, shaft length is 750 mm. Shaft is supported by two bearings, bearing A and bearing D. Okay, and input power is given in gear C, and that gear C is located 100 mm from bearing D, and gear B is located 150 mm from bearing A. This is what they have given in the question. Okay, one more thing they have given in the question. One more thing they are given in the question. The pinion having 30 teeth. That pinion delivers power horizontally to the right. Okay, va? So the pinion C is delivering the power. Okay, and pinion B receives the power. Pinion B receives the power, and pinion C delivers the power. That is, input is given on pinion B and output is taken on pinion C. This is what they are given. One more thing, how input is given or how output is taken, we will read it closely. Okay, delivers, read the fourth line. Okay, pinion C delivers power horizontally to the right. Okay, that means on the side of the gear C, that is pinion C, power will be delivered to another gear. Okay, va? Like this. If this is gear C or pinion C means it gives power to another gear horizontally. Okay, horizontally. Okay, that's what they have given in the question. Similarly, read the fifth line. Okay, the gear having 100 teeth of 5 mm module is located 150 mm to the right of the left hand bearing and receives power in a vertical direction from below. That means if gear B is like this means it receives power vertically downward direction. from the bottom side. Can you see it? See, I have drawn B is getting power from one more gear, and that particular gear is messing with the gear B like this in the bottom. In the bottom, these two gears are missing. But in case of C, on the side, that is horizontal direction, these two gears are missing. Okay. One more thing, they didn't give any direction like clockwise or anti-clockwise, like that. They didn't give any direction. Suppose if gear B rotates in clockwise, means gear C also rotates in clockwise, because both gears are attached in same shaft. Okay, both gears are attached in same shaft. I have taken like gear B is rotating clockwise, so gear C also rotating clockwise. Okay, va? Right. So gear C delivers the power to another gear. Okay, va? Gear C delivers power to another gear. So here gear C will be here pinion or driving gear, and the power which is delivered to another gear, no, that is called driven gear. So if two gears mess with each other, means there will be two kind of forces there. Okay, one is radial force and another one is tangential force. Two kind of force will be there. One is radial force and another is tangential force. Radial force, it will act towards the center of the gear. Radial force will act towards the center of the gear, and tangential force will act perpendicular to the radial. Tangential force will act perpendicular to the radius. Okay, and here gear C is rotating clockwise, so tangential force will be in the opposite direction. Okay, that is, tangential force will be always opposite to the rotation of the driving gear. Tangential force is always opposite to the rotation of the driving gear. Here driving gear is C. Okay, driving gear is C. So the tangential force on the messing point will be opposite to rotation of the gear C. But in case of gear B, gear B receives power. Gear B receives power. That means gear B is driven gear. Gear B is driven gear. Here also, while gear B mess with one more gear, it will have two kind of forces, radial force and tangential force. And radial force will act towards the center of the gear, center of the shaft. Okay, va? But tangential force will be perpendicular to the radial force. At the same time, since gear B receives power, receives means driven gear. Okay, if it is a driven gear, means tangential force will be in the same direction of the driven gear. In case of driving gear, tangential force will be in the opposite direction. Look at the arrow mark. Here PT moves upward, that is opposite to the direction of rotation of the gear C. But here PT moves leftward, that is direction of the towards the direction of the gear B. Okay, va? So in the question they didn't given the diagram. We have to read the question and we have to draw the diagram first. Okay, so it's a shaft. This shaft is supported by two bearings, bearing A and bearing D. See, they didn't give any name like A, B, C, D, like that. They didn't give any name. We have to name it by ourselves. So two bearings, bearing A and bearing D on either side, and it is having two gears. Gear B and gear C. First they are given about gear C. Gear C is gear C delivers power to one more gear that is attached to gear C. Okay, in the side both gears are attached in the horizontal direction like this. Okay, I have drawn semicircle, no, two semicircle. It represents two gears. This semicircle represents C, gear C. Here gear C is driving gear and this is driven gear. We don't know about the dimensions of that driven gear, but they transfer power in the horizontal direction. But here gear B, it receives power. Gear B, it receives power from one more gear in the bottom. That means they transfer power in the vertical direction. they transfer power in the vertical direction. Okay, and both are rotating in same direction. If gear B rotates in clockwise means gear C also rotates in clockwise, because both are attached in same shaft. Okay, so we have to draw PR and PT, that is radial force and tangential force. Every gear it will have two forces, one is radial and another one is tangential. Do you remember in the previous cases we have seen that it will have belt kind of bully arrangement. Okay, in the previous cases we solved two problems. There it will have bully arrangement. Bully arrangement means bully will have belt. Okay, so on the belt tensions, two kind of tension will be there, P1 and P2. Okay, but here PT PR. Here PT PR. PT means tangential force, PR means radial force. These things you might have studied in I think fourth module design of gear. There we may have studied about these things. Okay. Okay, right. Now let me go to given data. So what is they given? They given one more data, that is it is having an allowable shear stress of 54 megapascal. Okay. Let me write the given data first. So power they given 15 kilowatt. Okay. Then speed 200 rpm. Okay. Then number of teeth in the pinion, that is gear C. Number of teeth on the gear C is 30. And module for gear C is 5 mm. Okay, sorry for the disturbance. So module is 5 mm. Number of teeth in gear B is 100 and module is 5 mm. These things given in the question. And tau max value 54 megapascal. That means 54 Newton per mm square. What we have to find? We have to find out the diameter of the shaft. And the formula. They didn't tell us to use ASME method. Also, they didn't tell us to use rigidity based method. Okay, they didn't tell anything about those things. So, normal formula to find out the diameter. Tau max equal to 16 divided by pi d cube. Okay, into root of mb square in plus mt square. Root of mb square plus mt square. Now, in the question they are given tau max value, but we don't know mb value and mt value. Let us find those values first. First, let us find the mt value, because they are given power. No, they are given the power value, so we can easily find out mt value. So you know the formula for power. Power equal to 2 pi nt by 60. T means torque. Here T means mt, momental torque. Okay, 2 pi nt by 60. 2 pi n into mt by 60. So by substituting all the values, power 15 into 10 power 3 and speed rpm 200 rpm. By substituting all the details, we can get the mt value 716.197 Newton meter. Convert it into Newton millimeter, because we are going to find out the diameter. Diameter value will be in mm only. Okay. So if you keep it in meter means you will get very negligible value, like lot of digits you will get. So keep it in millimeter. So mt equal to 716197 Newton millimeter. Okay, 716197 Newton millimeter. Right. Next, so one data we got. Now we have to find out mb value. mb means bending moment. Okay, we have to find out bending moment at B and bending moment at C. Okay, and here two forces are there on B, and on C also two forces are there. On B, one force is vertical, PR is vertical, PT is horizontal. On C, PT is vertical, PR is horizontal. Okay, and PR and PT, both the force act in the upward direction. PR radial force of gear B and tangential force of gear C, both the forces are acting in upward direction, but the tangential force of gear B and tangential force of gear C are not acting in same direction. But while you are seeing this diagram, it look like both are acting towards left hand side. While seeing this diagram, it look like both are acting towards left hand side. Okay, but One is on the horizontal side of the shaft. Another one is on the bottom side of the shaft. Okay. This one. This PR is on the horizontal side of the shaft. Inward means it will look towards the shaft on the horizontal side. Okay, but this is on the bottom. PT of the gear B is on the bottom of the shaft. On the bottom of the shaft, looking this side means it will be in the opposite side. Okay. So two forces were there on two gears, PR and PT. We have to find out the PR PT of gear B and PR PT of gear C. They are given tau max value. So for that one formula is there. In design of gears, you might have studied these things. Okay, PT equal to that is tangential force equal to 2 into mt divided by d dash. D dash means pitch diameter of the gear. Okay, for any gear, tangential force will be equal to 2 into mt divided by d dash. For any gear, any spur gear particularly, here they didn't mention which gear is this, so let me consider this as spur gear. Okay, PR will be equal to PT into tan alpha. PR equal to PT into tan alpha. Again, alpha value they didn't give. We can take any value between 14.5 to 20 degree. 14.5 degree to 20 degree. We can take any value. For a safe design, I have taken 20 degree. Okay. Right. Now d dash, pitch diameter equal to module into number of teeth. D dash equal to module into number of teeth. Okay. So now we have to find out D dash for gear B, D dash for gear C. For gear B, module value is 5, number of teeth is 100. So answer is 500. Okay. For gear C, module value is 5, number of teeth is 30, so diameter value is 150. Okay. So we got diameter value. Okay. We have MT value. So now we can find out PT. So PT equal to 2 into, this is for gear B. For gear B, okay, diameter is 500. So PT for gear B is 2864. Similarly for gear C, PT for gear C, 2 into MT value 716197 divided by that diameter value 150. So 9549. Now you have to find out PR value. PR equal to PT into tan 20. Okay, for both the gears, for gear B and gear C. Find out the value. 1042 for gear B, 3475 for gear C. Now we have to draw the vertical plane and horizontal plane. Vertical plane load diagram, horizontal plane load diagram. So both on gear B, radial forces acting in the upward direction. On gear C, tangential forces acting on upward direction. So both forces you just write it. Okay, 10429549. But this reaction force, we don't know the direction of the reaction force. So I am putting in the upward direction. We don't know the direction of the reaction force. So I am putting it on the upward direction. So this reaction force also I don't know. So I am putting it in the upward direction. Okay. So I have to find out the reaction forces first. Then I have to draw the bending moment diagram. So since I have drawn everything in the upward direction, so for everything add all the upward forces. I have just added all the upward forces. Now take moment about A. Take moment about A. Okay, take moment about A. So at both ends, bending moment value will be 0. At A and at D, bending moment value will be 0. Okay. So I have taken point A. So here bending moment value is 0. If you want to find out moment about point A means, what are the forces there? First, force on the B. Force on the B is 1042 into 150. I have written it here. Force into distance. Okay. Next force on point C. 9549 into this distance. This distance is 500 plus 150. 650. I have written here. Next RAV. Sorry, RDV. Vertical reaction force on the point D. RDV into distance between D and A is 750. Write it here. So I got the answer now. I got the answer in minus. RDV is equal to minus 8484. Minus 8484 Newton. Since I got the answer in minus, I have to change the direction. Okay. So I initially I have drawn it in the upward direction. But I have to change it to downward direction. Okay. So now I am using this PPT. I couldn't change it, but while you are drawing, you change it. Initially I have drawn it in upward direction, but since I got the answer in minus, I have to change the direction as downward. RDV is acting downward direction. Similarly, next RAV. Substitute the RDV value in this equation. Minus 8484. Okay, minus 8484. Substitute here. You will get answer as minus 2107. Answer as minus 2107. Again, we got the answer in negative. So we have to change the direction to here RAV direction. Initially I drawn in the upward direction, but I have to change it to downward. RAV, see here, I have changed it. I have drawn in upward direction, but change it to downward. Okay. Now we have to draw the bending moment. Bending moment at A and at D, we know bending moment value is 0. So we will find out the bending moment at B and bending moment at C. Okay, bending moment at B and bending moment at C. Bending moment at B, I can come from this direction. If you come from this direction means I have two forces, but if I come from this direction means I have only one force. So I am coming from the left side. Okay, bending moment at B. Bending moment at B equal to, and this is acting downward. Downward means regarding point B, it is in the anti-clockwise direction. But from left side anti-clockwise means I have to put minus in front. Okay, so minus 2107. See here, last before line, minus 2107 into 150. Okay, I couldn't bring the red dot here. Okay, so minus 2107 into 150. Answer is minus 316050. Minus 316050. Similarly, bending moment at point C. And here one, if you come from right hand side means only one force will be there. So I am coming from right hand side. Okay, and the particular force is in the downward direction. RDV is in the downward direction. Initially I drawn it upward, but since I got the answer in negative, I would change the direction to downward direction. RDV downward. Downward means about point C, it is rotating in the clockwise direction. Since it is rotating clockwise direction, I have to put minus. Okay, minus 8484 into 100. Answer is minus 848400. So mark those points. Okay, since it is, we got both the answer in minus, we have to mark both the points downward. First point is 316050. Second point is 848400. Okay, so for vertical plane, all the diagrams were over. Next we will draw the diagram for horizontal plane. In horizontal plane, two reaction forces on A and D. Draw it. Okay, RAH, RAD. Draw it. Now on point B, one tangential force, and that tangential force is acting downward direction. Write it here. Okay, tangential force value is 2864. Write it here. Similarly, on point C, one radial force, and that is acting in the upward direction, and the value is 3475. Write that also. Okay. Now put the upward forces one side and put the downward forces on the other side. Next step. let us find moment at point A. Point A, moment value is 0. We know that. So 0 equal to, what are the forces there? On point B, PT is there. PT is 2864. Between point B and point C, point B and point A, distance is 150 mm. Write it down. 2864 into 150. Next to force. On point C, radial force is there. And the value is 3475. Between point C and point A, distance is 650 mm. 650 mm. Write it down. 3475 into 650. Okay. Since PT is clockwise, I put minus. But PR is anti-clockwise, so I put plus. Last one. RDH. RDH, that is also counterclockwise, and distance between D and A is 750 mm. RDH value I don't know, so I just put the variable RDH. Now find out the value. RDH is 2438. Okay, RDH is 2438. Now substitute the value in this formula. 2438 value in this formula. If you substitute means you will get RAH value, but we got the value in minus. Minus 3049. Minus 3049. So since I got the value in minus, change the direction. Initially I have drawn upward, but you change this one to downward. Reaction force A, change it to downward. Okay, what? Reaction force D, you can keep as it is because we got the answer in positive. But reaction force A, we got negative answer, so change the direction. Now we will find moment at point B. Find the moment at point B. Moment at point B, if I come from this side, two forces are there. If I come from right hand side means two forces are there. But if I come from left hand side means only one force is there. So it is somewhat easy for me. So I am coming from left hand side. So that force also downward direction. So that is counterclockwise. But since I am coming from left hand side, counterclockwise means minus. So minus 3049. Distance between A and B is 150. Now answer is minus 457350. Next, point C. Moment at point C. Moment at point C, it is if you come from right hand side means only one force is there. That is reaction force DH. So I take that force. RDH into distance between C and D is 100 mm. So 100. RDH value is 2438. 243800. One value is negative value, one value is positive. Positive, mark it above the line. Negative value, you just mark it below point B. Okay. Okay. Now we have see on point B, two bending moment value is there. About x-axis, about vertical plane, one bending moment 316050. About horizontal direction, also one bending moment is there. That is 457350. So on point B, two bending moment is there. On point C also two bending moment. In vertical direction 848400. In horizontal direction 243800. Two bending moment is there. Okay. So we have to find out the resultant bending moment. In horizontal we have one bending moment. In vertical we have one bending moment. Two bending moment is there. See here one bending moment, here one bending moment for point C. For point B also, in vertical one bending moment, in horizontal one bending moment. Two bending moment is there. We have to find out the resultant bending moment. Resultant value for B will be equal to root of 316050 square plus 457350 square. Similarly, for resultant bending moment for C will be equal to root of 848400 square plus 243800 square. Let us calculate the value. Okay, I have calculated it. The final answer. Bending moment for B is 555928. Bending moment for C is 882734. So we have to select the highest value. C is having the highest value 882734. Okay, highest value will be equal to MB. Okay, so bending moment at B we got the value. Bending moment at C we got the value. Compare both the value. Whichever the value is higher, that value we have to take as MB. Okay, 882734. We know that tau max equal to 16 divided by pi d cube into root of mb square plus mt square. That is the formula. So d cube came this side and tau max went here. 16 divided by pi into tau max 54 equal to root of mb square 882734 square plus mt square 716197 square. Substitute everything. D cube will be equal to 107209. So D value is equal to 47 mm. D value equal to 47 mm. That's all. Very simple. Very simple. Only one formula. Only one formula. This is only one formula. But you should know shear force diagram and bending moment diagram. Then only you can find out the MB value. In design of shaft, finding out the MB value is somewhat tricky. If you found out the value of MB means you can easily solve this problem. We will solve few more problems in the next classes.